not a problem because the people in the tank are in the tank, and any other person knows not to be behind the barrel when it fires because you get your eyebrows scorched off, right? Okay, and so what it does is the shell goes that way, the gases go that way, and it cancels part of the momentum of the shell, which minimizes the recoil of the cannon, which makes it easier to load. Yeah, isn't that cool? They have muzzle brakes for rifles. I imagine that they direct the blast downward or something so it doesn't like put your eyes out. Like, oh, geez, right? You know, that stings, right? Okay, and that is why you don't want to stand next to the end of the muzzle of a rifle. You don't want to be anywhere near. You don't want somebody to fire right here because there is an instant where the bullet is blocking the muzzle, and a fair amount of that blast goes laterally out when you fire like that. I know this because people that I shot with in Iowa weren't always terribly safety conscious. Okay, and so I got, you get stung by that the side blast. It was actually a handgun, but yeah, the blast goes sideways. If you see pictures, you ever seen pictures of a muzzle blast frozen in time? There's like a big fan out of the stuff, right? Okay, and then finally, okay, is there anybody here who does taekwondo or something? Yes. How are you supposed to punch? Is a punch just like, or is a punch technically you pull this arm back at the same time, so it's right? Aren't you doing that? Aren't you pulling one arm back at the same time you put the other one forward? At least that's what Jung Woo Jin showed me, right? Okay. Yeah, that's what you do is you pull this arm back. That's a momentum neutral thing. You're pulling one arm forcefully back, which puts a lot more power into the forward arm. Yeah. Keep your shoulders square, right? Yeah. Yeah. There we go. Momentum. It's all momentum. Where are we? Explosions. We need more explosions, don't we?
Yes.
More explosions. All right. Where are my cans? Where's my other can?
It's right next to the pencil string.
Oh, it's right there? Oh, there it is. I got it. All right. Now let's set up a more interesting explosion. Okay? And let's aim this can at Kyle. This one at Tex. Okay? And this one at me. There we go. All right. All righty. How are we ready? How are we ready? Fire the hole! Whoa, baby! Yeah! Whoa! That was not very impressive. Woo! Okay. I just love that. Kind of my counter's a little bit gritty. Now, that momentum looked like this. Some can went to this way, one can went that way, one can went to this way. Yes? Is it possible that these add up to 0? Yeah, in fact, if we drew these momentum vectors, right, it could be that one goes there, one goes like that, and the final momentum vector goes like this. So yeah, momentum's conserved in 3 dimensions, which is kind of a neat thing. And then the final thing about explosions, and this is a bit grim, but when an airplane breaks up, possibly because of like in Lockerbie, right, Scotland. This is something that Libya, Muammar Gaddafi actually bombed an airplane over Lockerbie, Scotland, and the airplane broke up at like 30,000 feet or something like that. Well, the airplane was moving with a particular mass and a particular velocity. After the explosion, the parts all moved off, right? But the momentum of all those parts was the same as the momentum of the plane before, right? So they can find the parts that way. That's one of the ways that you can find where the parts are. Okay. Yeah. That was grim. All right. Now we have, I believe, I don't think I need the projector. I think we've got the Murray mobiles. Okay. Now, for these Murray mobiles, I'm redesigning basically the way cars work. I ask the 2 things of you. The first thing is that you not steal my ideas and patent them before I do. Okay. The second thing I ask of you is that you not laugh at my designs. Okay. So here is the first Murray mobile. Well done. Okay, now there it is. And the notion was that this would be entirely pendulum powered. Okay, and all we have to do is cock the pendulum and let it go, and off the road, down the road I would go. And of course, you know, it doesn't work so well because I forgot the minus sign, right? You know. Okay. So in fact, when the pendulum's going forward, okay, the cart is going. I should never see that movie because I'll start stuttering again. I was a stutterer. I will become one again. Okay. When the pendulum's going forward, the cart will go backwards, and vice versa, right? And I just thought maybe the cart would go forward, and you know, that's kind of fun, right? Ah, it's sinking. It's falling down. There we go. Come on, dude. Go back up. There we go. Okay, so think about a milk truck half full of milk. Why don't they drive down the road like that? You know, it's like, I hate driving this truck. There we go. You'd think it would, right? With all the milk sloshing from end to end, right? And you know they have to drive them half full because they don't pick up all the milk at once, right? Whoa! Don't stop in front of me. Whoops. I suspect that big tanker trucks have baffles inside them, little things that go up and down that keep the waves from splashing. And they must, right? Otherwise it'd be just too much fun to drive. Woo! Oops, sorry. I'll back up. Okay. Little applause for Murray Mobile number 1. Yeah. Okay. Now, I knew that the problem with Murray Mobile number 1 was simply that the pendulum went back and forth, and so therefore the car did too. So I came up with Murray Mobile number 2, which was the notion with this one was that we would design all the roads to be basically like this frictionless track, and I thought that was a stroke of genius, you know, right there. Okay, just make all the roads frictionless, and then all we have to do is have these balloons attached to the cars like this, right, and just kind of blow those up. Et voila, huh? And I calculated that it would take a balloon approximately 30 meters in diameter to propel a car half a mile down the road. And you wouldn't believe the nitpickers and the naysayers and the, you know, how would you drive under a bridge? I mean, that's stupid, right? You know, these people are just, I think the people just like shooting you down, you know? They don't want to listen to your ideas. They just want to like put you down, all right? So I just, you know, I felt very discouraged. And so the next Murray Mobile, I believe, was somewhat unadvisable, but I think you could see why I got in that sort of negative space that I might design a Murray Mobile like that. Okay, and I regret designing this Murray Mobile, but at the same time, let's just see what it was all about, you know. You guys kind of want to like. All right.
Tanner's going right at you.
Fire in the hole! Boop! Yeah! Look at it go! Woo! Yeah! Right, so my design, there were many sticks of dynamite. There were many sticks of dynamite, and they would be like fed in, like one after another, right? Safety concerns. You know, who is worried about safety when you're just trying to get to the grocery store or something like that, right? I mean, it's just, you know, people are just driving me crazy, right? Okay, so the final Murray Mobile is the, well, okay, this is the second to final one. Okay, this is the methanol cannon. Okay. We're going to put, this is, put a little fuel air explosive in here, the poor man's atom bomb. Okay. Woo! They like the combination of those two words, Murray and atom bomb. So we want to point the camera so it's like pointed up here. All right. All right. And what I've got is I've got a couple nails in there, and they're not quite touching. Okay. And I know you guys are like worried about the nails. Don't be worried about the nails. The nails rarely, if ever, come loose and fly through the air.